In this video, we are going to be looking at second order homogeneous ordinary differential equations whose auxiliary equations have complex roots. So to begin, we are looking at problem 1, and we have to solve 2y prime prime plus 4y prime plus 3y equal to 0. So the first things first is to get the auxiliary equation. And the auxiliary equation can actually be gotten by, let me teach you the shortest way of getting it. So you're going to replace y prime prime with s square. You're going to replace y prime with s, and you're going to replace y with 1. So this is the trick. So the variable that I'm using for my auxiliary equation is s. Someone else might decide to use m, okay? And someone else might decide to use this other one here. This is lambda, okay? So for my auxiliary equation, I can pick from a plethora of variables. I like using s. Sometimes when I was learning with K.'s Stroud, we started using m, then lambda becomes kind of like more advanced. So let me use s for simplicity. So the auxiliary equation is going to be 2s squared plus 4s plus 3 equal to 0. So I'm going to solve this auxiliary equation using quadratic formula. S is equal to, remember, for a y squared plus b, if you can remember in our last video, for as squared plus bs plus c equal to 0, our s is equal to minus b plus minus the square root of b squared minus 4ac over 2a. So this is my a, this is my b, and this is my c. So I have minus b, okay, plus minus b is minus 4 plus or minus the square root of, okay, b squared, which is 4 squared minus 4ac 2, then 3 all over 2a, 2 times 2. Is that okay? So when we solve, we'll have s is equal to minus 4 plus or minus the square root of 16 minus 24 over 4. Okay, so when we solve, we'll have s is equal to minus 4 plus or minus the square root of negative 8 all over 4. This evaluates to minus 4 plus or minus I root 8 over 4. Okay, some people use I, some people use j. Okay, they are both standing for the imaginary number, which has a magnitude of square root of minus 1. So anyone you are familiar with, no problem, it's still okay. So remember that the square root of 8 is the square root of 4 times the square root of 2, and this is 2 root 2. So you can still simplify this to minus 4 plus or minus, we have let me use j. We have j 2 root 2 over 4. So at the end of the day, when you simplify s will be equal to minus 4 over 4 when you distribute the denominator, plus or minus j 2 root 2 over 4, and this leaves us with minus 1 plus or minus j root 2 over 2. So this is the complex value. So when we have gotten the roots of this particular quadratic equation, then what next? So you have to recall that for s in the form a plus or minus jb, our solution y is equal to exponential at into c1 cos bt plus c2 sin bt, where b, okay, and a, b is the imaginary part, a is the real part, then c1 and c2 are all arbitrary constants. So what we just need to do is to take these values and substitute it into the equation. So we will now have for this particular equation that our y is equal to exponential a is minus 1, so minus t into c1 cos b is having a value of root 2 over 2, root 2 over 2, root 2 over 2, then t, then plus, what do we have, c2 sine root 2 over 2t. Is that okay? So this is our y, and that is as far as we go. So for this problem, so quickly, I'm just going to do another problem. So in problem 2, we want to solve y prime prime minus y prime plus y equal to 0. So auxiliary equation, of course, we'll have s squared minus s plus 1 equal to 0. So do you remember the trick? Replace your y prime prime with x squared, then replace your y prime with s, and replace your y with 1. So when you solve this, you have s is equal to minus b, and b in this case is minus 1. So plus or minus the square root of b squared, which is minus 1 squared, and minus 4ac. We have 1 times 1 over 2a over 2a, which is 2 times 1. So if we solve this, we'll have 1 plus or minus the square root of 1 minus 4 all over 2. So if we solve, we'll have s is equal to 1 plus or minus the square root of negative 3 all over 2, which is 1 plus or minus j root 3 over 2, which is 1 over 2 plus or minus j root 3 over 2. So we have our characteristic equation to yield a complex root in this form. Therefore, our solution, general solution, is we have y equal to exponential this guy over here, which is 1 over 2t, then into c1 cos bt, which is root 3 over 2t, then plus c2 sine root 3 over 2t. So this happens when you solve second order differential equations, homogeneous differential equations, and when you have complex roots from your characteristic equation. This is the way you're going to format your general solution. Thank you for watching this video. Like and subscribe, share, hit the notification button to stay updated. Stay blessed. Okay.